Hello friends, welcome to this video lectures of experimental stress analysis. So today we'll discuss about the chapter number 8, computation of stresses, part 3. So before moving to this third part, we'll discuss about the part number 2, that is in the same chapter. In part number 2, what we have discussed. So in the part number 2, we have discussed about the basic applications of the strain gauge rosettes, that is how the strain gauges are used in the dynamic applications, and how such types of the strain gauges are works on such types of the dynamic applications, how the strain gauges are pasted at the different locations. So like that applications we have discussed in the last lecture. So in the part number 3, also in the part number 2, we have discussed about the numericals based on the strain rosette. So before solving the numericals, we have discussed about the important formulas. In that we have discussed one formula, that is we have discussed one table. In that table, that is how that given parameters, that is value of epsilon a, epsilon b and epsilon c, how that values are useful to calculate the values of epsilon x, epsilon y and the gamma xy. And then we have discussed about all the important formulas, that is unknown parameters which we have to calculate, that is the principal strains, principal stresses, their directions, then maximum shear stress, and last one is a tau max, that is maximum shear stress. Now in this part 3 of this particular lecture, again we are discussing about the numericals based on the rosette type of strain gauges. In the last lecture, we have solved the numericals based on the 3 element rectangular rosette. Also we have solved one numerical based on the t delta rosettes. Now again we'll discuss about how the numericals will be solved for the 4 element rectangular rosettes, then for the delta rosette. So again we are going to discuss the numericals based on the different types of the rosettes. Okay, so the third numerical, that I will read the statement, so and how this numericals will be solved to find out all the unknown parameters which we have to calculate. Now the third numerical is the strain readings is measured by the equiangular rosette at a point of stressed model are as follows. So whatever the strain gauge readings are taken from that particular equiangular rosette, that readings they have given, that is epsilon a is equal to 500 microstrain, epsilon b is equal to 380 microstrain, and epsilon c is equal to 200 micrometer per meter. But here in the third condition, the unit is somewhat different. That means if I will calculate this m and m, then I will get the only micro, or it can be represented in the form of microstrain. And what they have asked, determine the principal strain, that means epsilon 1, epsilon 2, stresses sigma 1, sigma 2, directions means we have to calculate the value of phi 1 and phi 2, then maximum shear stress, that is I have to calculate the tau max also. And what the given parameters they have given, that is take the Young's modulus, that is capital E is equal to 210 gigapascal, and value of mu is equal to 0.286. So this is the given parameters they have given, or this is the statement of the problem. So whatever the type of rosette they have mentioned, that is equiangular rosette. So that equiangular rosette is also called as a delta rosette. So there is a similarity between the 3 element rosette and the equiangular rosette or delta rosette, that is the number of strain gauges used in the 3 element rosette and a number of strain gauges used in the equiangular rosette or delta rosettes are same. Means in 3 element 3 strain gauges are there, in delta rosette the 3 strain gauges are there, but in 3 element rectangular rosettes the strain gauges are arranged in the form of rectangular form, but in equiangular rosette or in delta rosette the strain gauges are arranged in the form of equilateral triangle. So that nature or the configuration of that delta rosette and the 3 element rosette we have discussed in the classification of the strain gauge rosettes, and by using this particular equiangular rosette or the delta rosette we have to find out the further parameters. So as the type of rosette they have mentioned, that is equiangular rosette, which is also called as a delta rosette. So by using that particular equiangular or delta rosettes, I have to calculate the important values which we have to consider for the further calculation. So as if we go through the given data, that is value of epsilon A, epsilon B and epsilon C, only three readings are mentioned, because in delta rosette or in equiangular rosette only three strain gauges are there. Here if in addition to that, if epsilon D will be given, and that due to that epsilon D, the rosette becomes either 4 element rectangular rosette or the T delta rosette. So the problem related to the T delta rosette we have discussed in the last lecture. Now we'll solve the problem for the delta rosette or the equiangular rosette. So these are all the given parameters, that is epsilon A, epsilon B and epsilon C. But if we go through our unknown parameters, that is principal strain, principal stresses, direction, maximum shear stress, initially I have to calculate the values of epsilon x, epsilon y and gamma xy. But the values of epsilon x, epsilon y and gamma xy is not given in the statement of problems. But to calculate these three values, the values of epsilon A, epsilon B and epsilon C is given. So once again I have to take the reference of that particular table which is given in that particular formulas. In that particular table we have to identify the column of equiangular rosette or the delta rosette, and from that particular table I have to calculate the values of epsilon x, epsilon y and gamma xy from this particular three values, that is epsilon A, epsilon B and epsilon C. So now we'll start how the numericals will be solved. So for the equiangular rosette and delta rosette, from that particular tables, so initially I will calculate the first value, that is from that particular table I have written epsilon x is equal to epsilon A. The value of epsilon A is given, therefore epsilon x is equal to epsilon A is equal to 500 microstrain. I have taken that values of epsilon A as it is as a epsilon x. Then to calculate the epsilon y, again I have taken this particular formula from that particular table, and the value of epsilon y is calculated, that is epsilon y is equal to 1 by 3 into square bracket of minus epsilon A plus 2 epsilon B plus 2 epsilon C. So to calculate the values of epsilon A, so the formula is given. So in this particular formula, that 1 by 3 is the constant parameter, so you can write as it is minus epsilon A. So here minus sign is there, but value of epsilon A is given as only 500, so we have to take here minus 500 plus 2 into epsilon B. So 2 is as it is, into epsilon B is also given, that is 2 into 380 microstrain we have to put here, then plus 2 into epsilon C. Again 2 is the constant parameter, we have to keep as it is. The epsilon C is given 200 microstrain, so this epsilon C I have to put in this particular equation, and by solving this particular equation I will get the values of epsilon y is equal to 220 microstrain. And the third parameter, that is gamma xy, is equal to the formula I have taken from that particular table for the equiangular rosette, that is 2 upon root 3 in bracket epsilon b minus epsilon c. Again 2 by 3 is the constant, as it is we have to take epsilon b minus epsilon c. Once again I will take the epsilon b as a 380 microstrain and epsilon c as a 200 microstrain, and by solving this particular equation I will get the values of gamma xy is equal to 207.84 microstrain. So like that, by using the values of epsilon A, B and C, I have calculated the values of epsilon x, epsilon y and gamma xy by taking the reference of that particular table and by taking the formulas of the equiangular rosette or the delta rosette from that particular table. Once I will get these three values, then I can go to calculate our unknown parameters, that is first one, principal strains. So how the principal strains are calculated, that means I have to calculate the values of epsilon 1 and epsilon 2. So this is the basic formula which is available to calculate the principal strains. So the formula is given in the form of addition and in the form of subtraction. So again I have to put the values of epsilon x, that is whatever the epsilon x is calculated 500 microstrain, epsilon y is calculated 220 microstrain, and this particular gamma xy we have calculated 207.84 microstrain. So we have to put all these three values in the epsilon 1 and epsilon 2 equations, and by taking the addition first I can calculate the epsilon 1, which is equal to 534.35 microstrain by taking the addition of this particular two equation, and by putting the same values in this particular equation, but by taking the subtraction of this term and this term, I have calculated the values of epsilon 2, that is 185.64 microstrain. So these two values indicates the magnitude of the principal strains. Now the next parameter, that is principal stresses, that is I have to calculate the value of sigma 1 and sigma 2. Again the separate formulas are given for the sigma 1 calculation, the separate formula for the sigma 2 calculation. The values of E, if you go through the values of E, here it is given in gigapascal, but as I have to calculate the stresses in Newton per mm square, so we have to convert that particular E in the Newton per mm square. So the value is given in gigapascal. So to convert that particular value in the Newton per mm square, multiply by 10 raised to 3. Therefore, your value becomes 210 into 10 raised to 3 Newton per mm square. The mu value is as it is, we can take as it is. So by putting the values of Young's modulus E, then mu, and whatever the values of epsilon 1 and epsilon 2 we have calculated from this particular above equation, put the values of epsilon 1 and epsilon 2 in the sigma 1 equation, then again we have to multiply by 10 raised to minus 6 to obtain the sigma 1 in Newton per mm square, and by making the calculation of this particular whole equation, I will get the value of sigma 1 is equal to 134.35 Newton per mm square. Similarly, the formula for the sigma 2 is also given. Once again I have to put the value of Young's modulus, then mu, then I have to put the values of epsilon 1 and epsilon 2 here in the sigma 2 equation, and again we have to multiply by 10 raised to minus 6, and by solving this sigma 2 equation once again I will get the value of secondary principal stress, that is 77.41 Newton per mm square. That means by using the value of Young's modulus, mu and principal strains, I have calculated the values of principal stresses, that is sigma 1 and sigma 2 in the form of Newton per mm square. So like that the principal stresses we have calculated. Now next they have asked, that is direction of principal strains or direction of principal stresses. So again to calculate that directions in the form of phi 1 and phi 2. So to calculate the phi 1, the separate formula is available, that is the formula is 1/2 into tan inverse of gamma xy divided by sigma x minus sigma y. So 1 by 2 into tan inverse, this is the constant parameter. So in this particular equation we have to put the value of gamma xy, which we have calculated here, that is 207.84. we have to put that particular gamma xy in this particular equation. Epsilon x and epsilon y also we have calculated by taking the reference of that particular table, and by solving this particular equation I will get the phi 1 is equal to 18.29 degree, and that phi 1 represents the direction of first principal strain or direction of first principal stress. Then I have to calculate the value of phi 2, that phi 2 represents the direction of second principal strain and or direction of second principal stress, because whatever the strain is induced in that particular direction, in the same direction stress is also induced. And how that phi 2 is calculated? So formula for the phi 2 calculation is equal to phi 2 is equal to phi 1 plus 90 degree. So whatever the phi 1 I have calculated 18.29 degree, in that 18.29 only I have to add the 90 degree, and then I will get the direction of second principal stress, that is phi 2 is equal to 108.29 degree. So this is about the calculations of direction of principal stresses, or it is also called as a direction of principal strains. And the last parameter they have asked, that is maximum shear stress. So sorry, here it is not a strain, here maximum shear stress. So tau max is equal to sigma 1 minus sigma 2 divided by 2. This simple formula is available with us. So whatever the values of sigma 1 we have calculated, that is 134.35 and 77.41. According to that formula we have to take the subtraction, that is sigma 1 minus sigma 2 divided by 2, and by making this particular calculation I will get the maximum shear stress, that is tau max is equal to 105.88 Newton per mm square. So this is about the equiangular rosette, in which we have calculated the four parameters, that is principal strains, principal stresses, direction of principal stresses, and the maximum shear stress. So like that we have to solve the problems based on the equiangular rosette. Now, one more problem we'll discuss based on the strain gauge rosette. So, I will read the statement first. The following observations are made on delta rosettes for the still specimen. So, in the delta rosette, as we know that it is also called as equiangular rosette. So, whatever the last problem we have discussed, so in that problem is also based on the equiangular and the delta rosettes. So, as per the configuration of delta rosette, so only three strain gauges are there, and it is represented in the form of given data, that is the following observations are made in T delta rosette for the still specimen. So the values of epsilon A is equal to minus 500 microstrain, epsilon B is equal to 350 microstrain, and epsilon C is equal to 200 microstrain. So only three strain gauges are there. Therefore, the three strain readings are given in the parameters, that is the determine principal strain, that is epsilon 1 epsilon 2, principal stresses, that is sigma 1 sigma 2, maximum shear stress, that is tau max we have to calculate, direction of principal strain, that means I have to calculate the value of phi 1 and phi 2, provided that mu is equal to 0.3, it is the constant parameter which will be given. Young's modulus is equal to 2 into 10 raised to 5 Newton per mm square. All the value of E is given in Newton per mm square. So we can take that value as it is for the further calculation. So as per the given data, or as per the type of strain gauge rosette is mentioned in the statement, that is delta rosette. Sometimes in the statement another word is mentioned, that is equiangular rosette, but as I have already explained, the equiangular rosette is also called as a delta rosette. So as per the given parameters, that is value of epsilon A, epsilon B, and epsilon C, we have written as a given data. Remaining two constant parameters, that is mu and the Young's modulus E, is also given. Now as I have to calculate all these three parameters, that is principal strain, stresses, maximum shear, initially I have to calculate the value of epsilon X, epsilon Y, and gamma XY, but these values are not given. But to calculate these three values, the three values are given, that is epsilon A, epsilon B, and epsilon C, and by using this particular three values, and by taking the reference of that particular table which I have explained, and according to the type of delta rosette, I have to calculate the values of epsilon X, epsilon Y, and gamma XY. Therefore, for the delta rosette, from that particular table, I have written the value of epsilon X is equal to epsilon A is equal to minus 500 microstrain, because epsilon A is given as a minus 500. Therefore, I have to take, or I have to write as it is. Then epsilon Y, again the formula is given 1 by 3 into in square bracket minus epsilon A plus 2 into epsilon B plus 2 into epsilon C. So I have to put the values of epsilon A as a minus value I have to put here, then 2 into epsilon B, that is 350, I have to put here, multiply by 2, and plus again 2 is as it is, and again I have to multiply by epsilon C, that is 200 microstrain. And by putting this all the values in this particular epsilon Y equation, I have calculated the value of epsilon Y is equal to 533.33 microstrain. So this is the calculation of epsilon Y. Similarly, by taking the reference of same table, I have to calculate the gamma XY. The formula is available for the delta rosette from that particular table, 2 upon root 3 into in bracket epsilon B minus epsilon C. Again 2 upon root 3 is the constant, I have to take as it is, epsilon B minus epsilon C. So value of epsilon B 350, I have to put here, value of epsilon C I have to put here, that is 200, and by solving this particular gamma XY equation, I will get its value, that is gamma XY is equal to 173.20 microstrain. So like that, by using this particular three values and type of row set, and by taking the reference of that particular table, I have calculated the value of epsilon x, epsilon y and gamma xy, and then I will go to calculate the unknown parameter which they have asked in the statement. That is first, that is principal strain. So to calculate the principal strain, again this formula is available in the form of addition and in the form of subtraction. So these formulas are available in the form of epsilon x, epsilon y and gamma xy, which already we have calculated here. So put the value of epsilon x, epsilon y, gamma xy, and initially by taking the addition of this particular term and this particular term, I have calculated the epsilon 1. Therefore here if you go through the second step, so I have kept all the values of epsilon x, epsilon y plus minus as it is, then this 1/2 also as it is, once again epsilon x, epsilon y taking the square of bracket, gamma xy I have to put as it is, make it square, and by solving this particular equation I will get the epsilon y by making the addition and epsilon 2 by making the subtraction. So like that, here I have calculated the values of principal strain, that is epsilon 1 is equal to 540.53 microstrain by taking the addition, and epsilon 2 is equal to minus 507.20 microstrain by taking the subtraction. So like that I have calculated the values of principal strains. Now next, they have calculated, that is I have to calculate the value of principal stresses. So the separate formulas are available to calculate the sigma 1 and to calculate the sigma 2. So the first formula sigma 1, once again it is available in the form of Young's modulus, which is given, the mu, this constant parameter is also given, then value of epsilon 1 and epsilon 2 already we have calculated here. So this value of epsilon 1, epsilon 2, this Young's modulus and mu we have to put in this particular equation. So I have kept the value of E, then mu, then epsilon 1, then epsilon 2, and at the end I have multiplied by 10 raised to minus 6 to calculate the first principal stress in the Newton per mm square. So by solving this particular second equation, I have calculated sigma 1 is equal to 85.35 Newton per mm square. Similarly, the second formula is also available, that is sigma 2. Again this formula is available in the form of Young's modulus, then mu. So this particular term and this particular term is same for both the equation, that is for the sigma 1 and sigma 2. This term and this term is same, only difference in this particular equation and in this particular equation. So once again I have kept the value of E, I have kept the value of mu, I have put the value of epsilon 2 which already I have calculated, then I have kept the value of epsilon 1 already I have calculated and multiply by 10 raised to minus 6, and I will get the value of sigma 2 is equal to minus 75.83 Newton per mm square. So like that I have calculated sigma 1 and sigma 2, that is principal stresses. Then they have asked the maximum shear stress. So the simple formula is there with us, that is tau max is equal to sigma 1 minus sigma 2. So whatever the sigma 1 and sigma 2 I have calculated, by using this particular two values I have to calculate the tau max, that is maximum shear stress. So here I will calculate that particular two values. So by making the subtraction of this particular two equations, that is sigma 1 minus sigma 2, that is 85.35 minus minus 75.83. So by taking the subtraction of sigma 1 and sigma 2 and by divided by 2, I will calculate the tau max, and that tau max becomes 80.59 Newton per mm square. So here I have not done the calculations, so please make that calculations, and whatever the answer is obtained, that answer is 80.59 Newton per mm square, that is tau max is equal to 80.59 Newton per mm square. Then to calculate the directions, again the formula is available, that is to calculate the phi 1, the formula is available, 1/2 tan inverse of in bracket gamma xy divided by epsilon x minus epsilon y. By putting the value of gamma xy epsilon x and epsilon y, initially I will calculate the phi 1, and once the phi 1 is calculated, again to calculate the phi 2, the formula is available. Phi 2 is equal to phi 1 plus 90 degrees. So whatever the phi 1 value I have calculated, that in that phi 1 I have to add the 90 degree, and then I will calculate the phi 2, and that phi 1 and phi 2 represents the direction of principal stresses or the direction of principal strain. And by solving this particular two equations, I will get phi 1 is equal to 4.54 degree and phi 2 is equal to 94.54 degree. So like that, I have to calculate all the unknown parameters for the delta rho set. So this is also one more example we have discussed related to the delta rho set, which is also called as a equiangular rho set. So like that, we have to solve the numericals based on the strain rho set. So in the part 2 and in the part 3, we have discussed the numericals related to the three element rectangular rho set. Then T delta rho set, and then we have discussed about the delta rho set, which is also called as a equiangular rho set. So the procedure to solve all the numericals is same. So whatever the procedure I have explained, that is initially as per the given parameters, initially I have to calculate the values of epsilon x, epsilon y and gamma xy by taking the reference of that particular table, and that values are calculated by using the given parameters in the form of epsilon a to epsilon d. And once that values are calculated, then remaining five formulas, that is principal strain, principal stresses, maximum shear strain, maximum shear stress and direction of principal strains, these five formulas are common for all the type of rho sets. So this is about the numericals based on the strain gauge rho sets. Now we'll discuss about the some numericals which is asked in the examination. So in the examination, how the numericals will be asked. So just I will take the overview within the 5 minutes, that is how the numericals are asked in the examination. So if you go through the first statement, that is the strain gauge reading measured by the equiangular rho set. So equiangular rho set means the delta rho set is given. So as per that particular rho set, only three readings are given in the form of epsilon a, epsilon b and epsilon c, and the value of change modulus and mu is given. And once again we have to determine the principal strain, principal stresses, directions, maximum shear stress. So whatever this problem is asked, it is asked based on the equiangular rho set, that is the rectangular rho set. Then the second problem, that is for a rectangular rho set, the following observations are made. Only they have given the statement a rectangular rho set, but I don't know whether it is 3 element or whether it is 4 element. But if you go for the further statement, the following observations are made with the gauges mounted on the steel specimen. Epsilon a is equal to 550, epsilon b is equal to 250 and epsilon c is equal to 450. That means only three strain gauge readings are given, means whatever the rectangular rho set they have given, it is the 3 element rectangular rho set. But in addition to that, if they are mentioning epsilon d is also equal to something, at that time we have to consider this rectangular rho set as a 4 element rectangular rho set. And again we have to calculate the same parameters, that is principal strain, principal stresses and the principal angles, which is also called as a direction of principal strains. And then next again the third problem, the strain measurement made at a point with T delta rho set are epsilon a is equal to something, epsilon b is equal to something, epsilon c is equal to something and epsilon d is equal to something. So that means as per the T delta rho set, it consists of a 4 strain gauges. Therefore the 4 strain gauges will give the 4 readings. Therefore in the given data they have mentioned the epsilon a to epsilon d, and from that particular we can easily say that whatever the T delta rho set they have mentioned, it is correct. So again by using this particular three values, again I have to calculate the same parameters, that is principal strain, maximum shear strain, then direction of principal stresses. Like that we have to calculate all the unknown parameters. The next problem is also based on the T delta, again value of epsilon a to epsilon d, that means same problem is given once again. Then the next problem is based on the three element rectangular row set, that is value of epsilon a, epsilon b, epsilon c. That means only three strain gauges are there, therefore three readings they have mentioned. By using this particular equation, I have to calculate all the unknown parameters. So once again, the next problem, that is equiangular row set, then three element row set, then again equiangular row set, again three element row set. That means if you go through the numericals based on the strain gauge row sets, maximum focus they have given on only three types of row set. That is first one, three element rectangular row set, then second, delta row set, which is also called as a equiangular row set, and third one is a T delta row set. So based on this particular three row sets only, the numericals are asked in the examination. The procedure to solve all the numericals is same, that is according to the given data from epsilon a, b, c and d. From this particular values, initially I have to calculate the required parameters, that is epsilon x, epsilon y, gamma xy, by taking the reference of that particular table in which all the formulas are given. Once these three values, that is epsilon x, epsilon y and gamma xy is calculated, by using this particular three values, I can calculate the required parameter which they have asked in the statements, that is principal strains epsilon 1, epsilon 2, principal stresses sigma 1, sigma 2, principal strain directions, that is phi 1 and phi 2, maximum shear strength, that is gamma max, and last parameter, that is tau max, which is called as a maximum shear stress. Only these five parameters we have to calculate for all the types of row set. Therefore the procedure to solve all the types of numericals based on the all the types of row set is same. So this is about the numericals based on the rectangular numericals based on the all the types of row set. So like that we have discussed the numericals based on the row sets or the strain gauge row set. So in the part number 2 and the part number 3, we have mostly focused on the how the numericals are solved for the all the types of row sets. Thank you.